Happy learning! Today we're going to be working through solutions of linear equations and inequalities in one variable. Okay, so let's start with a definition. What is an equation? An equation is a statement that two quantities or algebraic expressions are equal. Okay, so let me give you a quick example. So for example, this is an equation. The quantity 3x minus 7 is equal to the quantity 2. Here, x is a variable or unknown. Okay, and our goal is going to be figure out what value of x satisfies this equation. So let's now talk about some of our techniques for actually solving equations, finding out which value of x satisfies this. Okay, so these are some properties of equalities. The first is called substitution. And it says the equation formed by substituting one expression for an equal expression is equivalent to the original equation. Okay, what does this mean? This means we can rewrite one or both of the sides of an equation to simplify the problem. So for example, if we have something like 3x minus 9 minus 2x plus 9 equals 4, we can simplify this left-hand side of the equation. That's what the substitution property says. 3x minus 2x is just x, and minus 9 plus 9 is just 0. So we can actually substitute the left-hand side of our equation with just x. So it says x equals 4, which happens to be the solution of the equation. Another property is addition. And that says you could add the same number to both sides of an equation. So you could add or subtract the same number to both sides of an equation. And that won't change the solution at all. So for example, if you had x minus 4 equals 6, we can add 4 to both sides of this equation, and that will give us this, it's not going to change the solution at all. So this is just going to be rewriting the equation to something a little easier to work with. So let's add 4 to both sides, and we get x equals 10, which again is the solution to this equation. And then the last property is multiplication, which is just like the addition property, except there's one subtle difference. So the multiplication property says you can multiply or divide any non-zero number to both sides of an equation. All right, and so, for example, if we had 1/3 x equals 6, one way to rewrite this equation is multiplying both sides of this equation by 3. Okay, 3 times the third is 1, so this is just 1x, or x equals 18. All right, so these are the tools we're going to use to solve equations. So let's look at an example. And I recommend that you pause the video when I'm done writing out the example so you could try it on your own before I actually show you the solution. All right, so in this example, we're going to solve for x. And there's two of them. So the first one is 2x over 3 equals minus 6. And then the second is 3x plus 1 over 2 equals x over 3 minus 3. All right, so pause the video, try these on your own, but I'm going to work through them now. All right, let's start with A. So we have 2x over 3 equals minus 6. I'm going to multiply both sides by 3 to get rid of the denominators, because those are kind of a pain to work with. And we have 2x equals negative 18. And now I'm going to divide both sides by 2, and we get x equals negative 9. OK, and you could check if you sub in negative 9 for x, 2 times negative 9 divided by 3 is negative 6. So that is correct. And now with this next one, we have 3x plus 1 over 2 equals x over 3 minus 3. I'm going to multiply both sides of this equation by not 2 or 3, but actually 2 times 3, 6. And that's going to get rid of all the denominators. All right, 6 over 2 is 3. So we have 3 times 3x plus 1 equals. And now this 6 gets multiplied to both terms inside the parentheses. Remember the distributive property of multiplication. 6 over 3 is 2. So we have 2x minus 18. And now let's distribute this 3 in, and then we'll combine like terms. 9x plus 3 equals 2x minus 18. I want all the x's on one side, all the constants on the other side. So I'm going to subtract over the 2x, subtract over the 3. And we get 7x equals negative 21, or x equals negative 3. Right? That last step, I just divided both sides by 7. All right, so far, so good. Let's now take a look at a word problem. So the word problem is the number of dogs in the US is modeled by the equation y equals 0.876x plus 6.084 million. X, what is X? X is the number of years since 1990. All right, and the question is, in what year will the projected population be 36.74 million? All right, so try this again. Try this on your own. Please pause the video and try it. It's really easy to just watch me solve the problems, but you're not going to learn unless you actually try them on your own. So please pause the video and try. But what do we have? So in what year? We're going to try to find X, right? X is representing years. Is the projected population 36.74 million? So that's going to be Y. So we're going to have Y is 36.74, and then we're going to solve for X. So 36.74 equals 0.876x plus 6.084. Okay, and so we could subtract 6.084 from both sides. And we get 30.656 equals 0.876x. Dividing both sides by 0.876 gives us x equals 34.995. All right, but keep in mind, this is the number of years after 1990. So what year will there be about 36.74 million dogs in the United States? Well, 1990 plus 35. So the year would be 2025. Okay, and so in each of these examples so far, we haven't had an x in the denominator. It's possible that we'll see some examples with x in the denominator. And if that's the case, we just have to make sure to check our answer at the end, because we can't multiply or divide by 0, which might accidentally happen when clearing our denominators. So let's take a look at that kind of example. All right, so let's solve for x. First one is 3x over 2x plus 10 equals 1 plus 2 over 2x plus 10. And then the second one is 2x minus 1 over x minus 3 equals 4 plus 5 over x minus 3. Okay, so let's start with A. I'm going to multiply both sides of our equation by 2x plus 10. All right, the point of this is to get rid of our denominators. So on the left-hand side, 2x plus 10 over 2x plus 10, that's just 1. We're left with 3x. On the right-hand side, we have to distribute because we're separated by plus here. So we're going to distribute the 2x plus 10 to the 1 and to this fraction. That gives us 2x plus 10 plus 2 over 2x plus 10 times 2x plus 10 is just 2. Let's combine like terms and bring the 2x over. So minus 2x, minus 2x. We have x equals 12. Okay, and since we have an x in our denominator, we need to check our answer. All right, so let's check. So we check by just subbing in x equals 12 into our equation. So we have 3 times 12 over 2 times 12 plus 10. Is that equal to 1 plus 2 over 2 times 12 plus 10? Well, you could type this into a calculator, and it is correct. Really, what we're worried about is dividing by 0. And notice our denominators, neither of these is 0. So we're good to go. Let's take a look at the second one now. All right, so we have 2x minus 1 over x minus 3 equals 4 plus 5 over x minus 3. Just like the last example, let's multiply both sides by our denominator so we could get rid of the denominators. The left-hand side just becomes 2x minus 1. And the right-hand side, again, it's going to distribute. So we have 4 times x minus 3 plus 5. Let's distribute the 4 and combine like terms. So 2x minus 1 equals 4x minus 12 plus 5. I'm going to add 1 to both sides, and I'm going to subtract 4 from both sides. And we have minus 2x equals, well, negative 6. Dividing both sides by negative 2, we have x equals 3. So you might be thinking, x equals 3 is the answer. We need to check our answer. So we check. Is it true that 2 times 3 minus 1 over 3 minus 3 equals, well, we don't even have to look at the rest. We have division by 0. You cannot divide by 0. That's an undefined, it's undefined, it's not a number. Okay, so since we have division by 0, we're done. We know the answer is no solution. So it is possible that some of these equations actually have no solution, and that's okay. So we're going to be solving a lot of equations, but another type of problem we could look at is inequalities. So let's define what an inequality is. An inequality is a statement that one quantity is greater than another. All right, so for example, we could have a statement like x is greater than or equal to 7. This is an inequality. It says the quantity x is greater than or equal to 7. We could write this in what's known as interval notation. The values x takes on are 7. This hard bracket means included. We would use parentheses if there was no equal to here. And the biggest x could be is basically infinity, but it's not included. So this is the interval notation. These are two ways to write the same exact thing. And we could also do it graphically. So if we have our number line here, the values x take on is 7 and bigger. So all three of these are different ways to represent the same inequality. And so you solve inequalities just like equations, but if you multiply or divide by a negative, you have to flip the direction of the inequality symbol. Okay, so for example, just to see if you believe this, negative 2 is less than negative 1. Right? This is a fact. Negative 2 is further left on the number line than negative 1. If we multiply everything by negative 1, we still want a true statement. So that would give us 2 and 1. Well, to make sense, we'd have to say 2 is greater than 1. So we flip the inequality because we multiplied by negative 1. Okay, so let's finish up by doing just a quick example of solving an inequality and graphing our solution. All right, and so let's do negative 3x minus 2 is greater than 7. All right, and so let's add 2 to both sides. Adding, we don't have to change any of the symbols. We don't have to change the inequality at all. So we have negative 3x is greater than 9. And now let's divide by negative 3. So that means we have to flip the inequality. This gives us x is less than negative 3. In interval notation, that's negative infinity, comma 3, parenthesis, because we don't have the equal to sign. But we want to graph the solution. So let's get our number line out, mark off negative 3. We're going to do an open circle since we don't have the equal to sign, and we're going to go all the way to the left. All right, well, I hope you enjoyed this video, and let me know in the comments if you have any feedback. All right, take care. See you later.